Alright guys, what's up? Welcome to the first review preview session for ENGI 1331. I appreciate you guys joining me on the Sunday night. Before we get into MATLAB, I want to run through the logistics of how these sessions are going to work, what they are, when they're going to be, so you guys can kind of get a feel for what they are. So these sessions are basically just supplementary material for you guys. They're a review of lecture material from the past week and a preview of lecture material for the next week. We'll mostly be working in MATLAB, just like in lecture. I'm also going to be keeping a function sheet for you guys in Google Docs. So as we go through different functions, these are some of the functions I'm going to cover today. I'm going to put the function and its syntax down, its description, and some notes if I make anything about it. This is going to be linked on the announcement for when these videos get posted on YouTube. It'll probably be in the YouTube link as well, so you won't have any trouble getting to this. I'll mostly be presenting my own material, so any questions you guys have should be directed at it, and by that I mean I won't be answering questions directly related to like the MAs or other assignments. The material will be pretty similar to the material covered in lecture, so hopefully it'll spur any or answer any final questions that you guys have, right? These sessions are going to be weekly, every Sunday at 5 p.m. at the moment. So depending on the attendance rate I get for the first 3 weeks, these sessions could either move date and time. We could have a maximum of 2 sessions every week, or I could move to no session at all and just videos on YouTube. These sessions are obviously going to be held in the Zoom UTA office hours link. Obviously, it'll be me, Javi, hosting them. I don't know if I said that. Lastly, there are 2 things that I hope you guys get out of this. I hope you guys kind of finalize your understanding of the past week's lecture material before we move on to the next week. And the second thing I hope you guys get out of it is I hope you guys develop a sort of framework for the new material next week. All right, so with that, we can go ahead and jump into MATLAB. So when you launch MATLAB, you're going to see you're going to see this window, right? You're going to see a window that has a bunch of sub windows in it, a bunch of buttons in it, but all these buttons and windows do different things, right? So when you open up, you're going to have a current folder window, command window, and a workspace. With your current folder window, it's basically a window that shows what folder you're working in at the time, right? So it MATLAB, when the MATLAB runs, all of your files that you're, say, loading in or outputting, and the script itself that you're writing has to be in this current folder. So say I needed to work in myself, I need to work out of my desktop, right? And my desktop is itself a folder, so I have all of the files I need to either import or my script that I'd be running out of, right? And the way I like to use this is I like to actually hit this button right here, which basically opens a pop-up window. It's a lot easier to move around, so I could go into like my TA folder, my thermo folder, pull out a file real quick. It's a lot easier than just having to click these downshift arrows, right? So with these layouts, they're movable, right? So you can move all this stuff around pertaining to how you like it. This is how I like it. There's no right or wrong concept, but we find that sometimes on exams, students will have a problem where, say, their command window has been, for some reason, popping up as a separate window, and they don't know how to fix it. What you can do is just hit dock again. It'll dock it right back in place. And if you ever have a problem where your command window is missing, you don't know how to replace it, just hit default again. It'll reset you to the default layout. So the next 2 windows I like to get into are the command window and the editor window. Command window is obviously right here. The editor window will open if you click this button right here and open a new blank script. Instead of doing that, I'm going to go ahead and open a script I already have saved for this session from my current folder. So here we have the editor window and the command window. These 2 windows are the 2 windows we're going to be typing code in. So it's gonna be where we're coding RMAs. It's gonna be where we're running through in-class assignments, all that stuff. There are 2 main differences between the editor window and the command window. In the command window, you can only type in single lines of code. So if I type in A becomes 5 and I hit enter, MATLAB spits back out at me, A is 5, and A is sorted with the value of 5 in our workspace, right? But if I hit enter again, it won't run any of the code I had above it, right? In the editor window, we can hit a equals 5 again, hit enter, and we can keep adding lines of code. And so this is useful when you're trying to, code your MAs, right? You don't want to have to keep typing in your whole MA every time you want to run it and make sure it works, right? So that's what the editor window is for. It allows us to basically revise our code. One trick about the command window is if you hit up on the D-pad, you'll see all the past things that you've entered. And these can be useful when you're testing your code. So sometimes we'll ask for a lot of user input in our MAs. And so it's a lot easier to just scroll up and see what you put in last for the last user input and hit enter. The second difference between the editor window and the command window is the command window is where we're going to see all our output, right? So if I go to the editor window and I type in fprintf hey, it's going to output hey to the command window. Our workspace is where our variables are held. So if you see right here, we assigned a to 5 in the command window, go over to the workspace, and a became the value of 5, right? And so a is just a variable that we assigned 5 to. So next I want to jump into data types. So these variables can store different data, right? And there's different data types. Okay, so we got A right here, right? A is a 1x1 double. And a double is basically just a number. It can be an integer, it can have decimal numbers. As you can see, B, which is 5.5 with a decimal, it's also a double. It's basically anything numerical, right? C is a string. So a string is basically just a container for pieces of text. It can be multi-dimensional. So say this is single dimensional. It's a 1x1. It's one cell. It's a point. But we could have one where it has multiple rows, multiple columns, and that has to deal with multi-dimensional variables, which is something we'll get into at the end of this video. D is a char. So as you can see, D is a 1x2 char. It's a 1x1 cell, but it's a 1x2 char. So 1x2 char means it's one dimensional, right? But it counts the number of characters it has in it, right? So you'll get this whole one-dimensional, multi-dimensional thing when I go over multi-dimensional variables later in the video. E and F, they're logicals. If you see that right here, I said E is true. Instead of storing the word true in E, it's stored a 1. And then for F, I said F is false, and F it's stored a logical of 0, right? So E, you see has a 1. 1 corresponds to true, 0 corresponds to false. We can now talk about what I wanted to talk about next, which are comments and sections. So comments and sections are basically just lines of code that don't run when your code is run, right? So let's just say, like a certain kind of comments you want to have is maybe the name on your code, right? Or the section that you have on your code. Your MAs are going to have a lot of required text on your code that you're going to need to have, like task headers and say explanation of variables, identification of knowns, constants, and stuff like that. And Rafa actually has a pretty good video on that. So I'm going to go ahead and send that out to y'all when I finish this. So I'm going to put it as a link when I post it on Blackboard so you can see that as well. His video kind of goes over what everything you'll need for an MA. Line of code real quick. We hit run. Nothing's going to come out, right? Because it's commented. If I take the comment off, it'll run. So this is good for like maybe like editing your code out, right? So like say you had a bunch of block of code and it just wasn't working, but you needed to move on to the next task. You can just highlight it, click this comment button right here. It'll comment everything out so you can just move past it. Then maybe work on it later. And whenever you want to uncomment it, you can just hit this button right here. It'll uncomment it. The next thing I want to go over are sections. I got 2 sections right here. Problem 1, problem 2. And so if my assignment in problem 1 is to write hello to the command window, and my assignment in problem 2 is to write hey to the command window, I can click in these sections and you can tell that I have them, I'm inside a section because it's highlighted yellow. I can click run section, and it'll only run, well, did it again. You see how it only prints out hello, right? And then if I click on problem 2, it only print out hey. So going back to when we were assigning variables, you see how every time I assign a variable in my code and I run it, it prints it out to the command window. It's just basically just telling us what we know. I said A is 5, and it said, okay, A is 5. B is 6, okay, B is 6. You know, it's basically just telling us what we already know, right? So there's something you want to put after almost every line of code, which is a semicolon. And what the semicolon does is it suppresses the output of whatever's going on in your code, right? So you see that it's not popping up anymore. This next section of what I want to talk about, which are functions. So functions are basically things that we can call in our code to perform different tasks, right? So there's certain keywords that we can call and give them certain inputs and get a certain output. So like there's a function called max, where if we take a set of data and we use a max function, the max function will actually go in and find the maximum number in that set of data, right? The 3 functions I'd like to introduce at first are the housekeeping commands, is what we call them. So these are 3 functions right here. Each of them do a different thing. They don't have to be blocked up like this, but what they basically do is they clear out our workspace. They clear out everything that we've done from past code and start fresh. They give us like a clean slate kind of thing, right? So if I hit run section with these commands in here, it clears my command window. It clears all the variables, right? And you see how, like I said, functions are just keywords, right? And so if we were to do the max function, say A is the max of, and then we'd say we put the inputs inside the parentheses, right? So if you look here and we open the parentheses right here, you actually do have a drop-down menu that tells you everything you're going to need for all the inputs you'll need for a function, right? So all the inputs, so A would be the variable of what we're trying to take the max of, right? And sometimes this notation can get kind of confusing, so there's always this help menu right here. You can click on this and look up any function. So if you looked up max, a help menu would pop up, a dictionary basically. It just tells us like the syntax of how it works and stuff like that. This is a very helpful tool if you learn how to use it. And I do recommend learning how to use it because it's relatively simple just to figure out, you know, how to use a function based on just the descriptions they have here. There's examples, stuff like that. Like I said, I'm going to keep this function sheet updated for you guys. So we already got our housekeeping commands on there. We got a description of what they do. So the close command basically closes any figure windows. So say we had graphs and images output to the user for them to look at after running their code. Closes all those windows and basically just resets our display to look all nice for the next kind of code we're running. Deletes saved variables. So by that I mean it clears out the workspace, right? It cleared out all the variables, all the names, all the values. They don't exist anymore, right? CLC clears the command window. So CLC would be like, so say I had A equals to 5 again. CLC just clears it up, makes it look all nice, right? So the next function that I would like to get into and that you guys have seen me use throughout this video is Fprintf. So Fprintf is a function that by our means, are basically just going to be using to print stuff out to the command window. So like you saw, hit run section, it'll print out hey to the command window, right? There's different syntax with Fprintf. So like I said, functions are usually just keywords. We open the parentheses and then it asks for certain stuff, right? So Fprintf, like I said, we can print out stuff to the command window. We can print out whatever we want. We can print out whatever sentence we want. We could add variables to it. We could add numbers in there. We could add strings in there, depending on certain syntax, right? So let's just say we had the mass is. So if we were to put 25 here, we could print that out. The mass is 25, right? But if we wanted to hold a variable here, what we could do say a equals to 25, right? What we can do here is put a percent sign, 0.0f. This percent followed by 0. Whatever f is basically the placeholder for where our number is going to go, right? So we got this statement, we got the placeholder for where our variable is going to go. Now we need to tell Fprintf what variable we want to put there, right? So we put a. So now what it's going to do is it's going to format this string. It's going to format this string and fit a into this slot and then print it out to the command window. Right, it'll say something else. So let's say we want this to be 45, right? So this 0.0 right here doesn't always have to be 0.0. So let's say we had 0.1, 2, 3, 4, 5, 6, 7, 8, right? This 0.0 right here, if I change this to say 0.2, I run the section, I have 45.12. So what it does is it dictates the amount of decimal places that we're going to have when we print it out to the command window. 45 still has this value. I mean, A still has this value of 45 point whatever, right? But Fprintf will format this number according to the decimal places that we have. So another thing that we can have inside of our Fprintf statements are strings. So let's say and to substitute a string into a Fprintf, we just use a %s. So we'd hit S right here. So basically it's saying this variable is going to go into this placeholder and it's going to print this out to the command window. My name is Avi, right? We can include multiple. So let's just say the mass. The material is, the mass is. So right here we'd put %s, right? Because we want the string. And %0.0f, right? And so you see how this %s is in front of this %0.0f in our statement? Whenever we enter these, whatever variables are going to go into these spots, they need to be in order, right? So this needs to go S, A. Those are really the only key points with Fprintf. The next function I'd like to go over is input. So like I said, we can, if we had an Fprintf say, the material is right, %s, comma, let's say mat, and we define a variable mat. What we could have done last time, or what we did do last time, is we defined it as some name, right? This time what we can do with the input function is ask the user to input the name. So as you see here, we hit it, we type in the keyword input, we open the parentheses, and we get something that says prompt, right? We need our prompt. So let's say, what is the material? And another thing that you saw when I opened the parentheses was this S right here. This S is only included when we're asking for a string. So I run this. What is the material? Let's say copper. The material is copper. So what I did was I asked for the user to input the name of the material, right? Copper, I typed in copper. Copper was stored as a char inside the variable mat, as we see in our workspace. And then when Fprintf was run, mat, the variable, whatever was stored in the variable was put in place of %s and then printed out to the command window. So like I said, these functions are basically just keywords followed by parentheses, open parentheses, right? So you don't want to think of them as just keywords, right? Because these functions, like I said, are taking an input, they're doing something behind the scenes, and they're giving us an output, right? So I got a quick example right here. This function right here is what I called sort max or min to max. And what it does is it takes a variable, it sorts the numbers in it from minimum to maximum number, right? And so this function, as you can see, it's nothing but just a block of code, right? It takes some inputs, it runs some code in code that we can understand, and then has an output. and puts it back into the script. So writing our own functions are going to be something that we cover later in the semester. But for now, just don't think of them as only, keywords. Think of them as something going on in the background. They're actual blocks of code, right? So the next thing I'd like to get into in this video is a topic that you guys haven't seen before. You probably have seen it on Zybooks, but you haven't heard it in lecture yet, which are multi-dimensional variables. Multi-dimensional variables are variables with various dimensions, or like vectors, right? So you got within a vector, you have your I, your J, and your K components, right? So vectors are sets of data. So let's say 1, 2, 3. We could think of this as I, J, K components, right? So I hit run section right here. A is stored as now a 1/3 double, right? So before we were seeing, let's say X is 1. Before we were seeing variables 1 by 1, right? Now we see A is a 1/3. 1 by 1 corresponds to however many rows it has and however many columns it has. If we go to A, it's a 1/3. 1 row and 3 separate columns, right? B we'll define as another vector, but this one's going to be a little different. B, as you can see, it's different than A, right? And the reason for that is because of these semicolons right here. So what these semicolons do is instead of a space or also a comma, this will work as well. The spaces after the commas really don't mean anything, so you don't have to worry about that. I like to do it with spaces. You can do it with spaces or commas or spaces and commas. It doesn't matter. It doesn't affect the syntax, right? It's still the same thing. So like I said, A is different than B, right? A seems to be 1 row by 7 columns, and B is 7 rows by 1 column, right? And so what we like to, when vectors are like this, we like to call them either row vectors or column vectors. So A is a row vector because it's 1 row, and B is a column vector because it's 1 column. But when a data set, or when a variable includes both semicolons and commas, we get a 2-dimensional set of data. So now, as you can see, I said 1, 2, semicolon, 3, 4, right? And so the point of that is 1, right, comma, meaning we're going to assign it to the next column, like in the row vector. The semicolon then jumps to the next line and then assigns everything else with a comma separating them as the next column, right? So that's the syntax for the what we call a matrix. These multidimensional variables can be indexed, meaning we can go into a certain one of these boxes or cells and pull out the value in these boxes, right? So we could say, let's say, the way I like to think about these matrices is think of them as like, say, like a dorm building, right? You got your floors as your rows and your columns as, say, whoever's above and below you, right? And so let's just say Luke lived in building M, right? Let's say row 2, column 3. So he lives in building M at row 2, column 3. We hit run section. Row 2, column 3 holds a value of 7. And Luke, as we go to our workspace, also holds a value of 7. So let's just say I would have typed 3, 3. Row 3, column 3. Right, there's nothing there. So when I do that, MATLAB recognizes that we're out of our range, right? Nobody lives in row 3. There's nobody there. So nothing is stored in Luke, meaning there's an error, right? You can't store nothing. And so it tells us this by the index in position 1. Position 1 exceeds array bounds, must not exceed 2, which is the amount of rows we have, right? Vectors can be indexed the same way, right? So let's just say Ryan lives in building A, vector A, at row 1, since that's the only row we have, right? Column 5, which should hold the value 5. Ryan has a value of 5. Row 1, column 5. Another way these vectors can be indexed is we could just, MATLAB will know that it's a vector, and what you can do is index it at the only changing dimension, right? So here, the changing dimension is the column, right? And we picked only 5, and so we went to column 5 and grabbed the value of 5. Vectors and matrices can be concatenated, but there are certain things that we have to satisfy before we can concatenate them. So let's just say we have A equals, let's say 1, 2, 3, 4 again. B equals, so we got a row vector and a column vector. If we say, let's say matrix becomes, we try to say A, comma, B, right? We try to run this. What it's saying is it's trying to create a matrix with A next to B on the same row, right? Because we used a comma. We get an error because it says the dimensions of the arrays being concatenated are not consistent. So we tried to have A, right? A was first. And then we tried to place B on the next row, like this, right? That's not going to work with MATLAB. The reason for that is because we have all this empty space right here. Whenever we're trying to concatenate two vectors or two matrices, we must satisfy, it's basically what I like to call the rectangle rule. And we have to we have to fill a full rectangle, right? So we can't have B being right here, right? Because it's a column vector. And we can't have A being right here because it's a row vector, right? So another way to look at this rectangle rule I've been talking about is whenever you're putting two sets of data next to each other, so almost like on the same row, you want to make sure their number of rows adds up. And so by that I mean, if I go to variables, I go to A. A is 2 rows by 5 columns, right? B is also 2 rows by 5 columns. So when I put them together, 2 rows by 5, 2 rows by 5. B could have had an extra column, but as long as that column had 2 rows, it would have concatenated well in MATLAB. And if I do, so new mat 1, new mat 2, it's A colon B, so I want to put B under A now. That'll also work because it also has 5 columns, right? Run A, B. And B could have not had this row, and it still would have satisfied what MATLAB wants, right? So these multi-dimensional sets of data can also be included in mathematical equations. And so as you see here, we have a matrix A, which is a 2 by 5, and B, which is a 5 by 2. We say new becomes A times B. New becomes a 2 by 2. And the reason for that is because we're taking, the way matrix multiplication works, is we're taking this row times this column first, element by element, and storing it right here. And by that I mean we're taking 1 times 56 plus 2 times 68 plus 3 times 90, and so on. And the final product goes into this space right here, because that corresponds to the first row of A times the first column of B goes in the first row, first column of new. And so next we take the first row again, but then multiply it by the second column, element by element, and store it here. Then we move on to the next row, first column again, stored here. And so what this is basically the dot product, right? There is also another way to multiply two sets of data together. So if we put, say we have two vectors right here of the same size, both 1 by 4s, right? One row by 4 columns, and we say A times B. If we run this, we'll get an error, right? Because if we go here, we say A, B, we're trying to multiply this row by this column, right? But as you see, if we try to multiply 1 by 1, it'll accept that, and then we add 2 times nothing. That's why it doesn't work, because we can't multiply it by nothing, right? But if we put a dot operator in front of this multiplication sign and hit run, it works. The reason for that is because what the dot does is it automatically assumes element by element multiplication. So what that means is 1 got multiplied by 1, 2 got multiplied by 2, 3 by 3, and 4 by 4, and so on. And new became 1, 4, 9, and 16, right? Because it was basically the same as squaring A, but instead we just multiplied it by itself, basically. Operators that require this dot in front of them for element by element are multiplication and division. Addition and subtraction are already element by element themselves. So if we say A plus B, new is 2, 4, 6, 8. Right, we just doubled it. We can also multiply these sets of data by scalars. And so that is automatically element by element. So if we say 3 times A, we don't need to put a dot there because it's a scalar times a vector. So new is now 3 times A. So there are some functions that utilize multi-dimensional data. Two of them I'd like to go over today are max and min. And as I said earlier, max and min, well, what max does is it goes into a set of data and it pulls out the maximum number, right? And so you can assume min, what it does is it pulls out the minimum number, right? So let's say m equals max of, let's start with a vector c. M stores the value of 4. If we go into c, 4 was the maximum number stored in c, right? Let's try this with a matrix, A. So A is now two-dimensional. We run it. M now comes back with a 1 by 5 vector, right? And the reason for that is because whenever we put a matrix into the max function, it takes a maximum corresponding to column, right? Because whenever you see a matrix, there could be different ways to take maximum with respect to, right? We could be taking the maximum with respect to the column, so in this case 6, in this case 7, and so on. We could take the maximum with respect to the row, in this case 5, in this case 10, or we could take the maximum with respect to the whole thing, in this case 10. And so the way to get max to realize what kind of maximum we want to take, we put in these brackets right here, and we put in a dimension. So when there's no dimension, it automatically assumes, like I said, it takes it by column, right? If we put a 2 here, we're left with a column vector. And as you can see, it took the maximum corresponding to row, right? If we put a all here, it takes a maximum with respect to the entire set of data, right? And so it's the same way with min. Type in min. Let's do it again without anything. Takes a minimum with respect to the column, right? These brackets with respect to the row, right? With respect to all. So as you can see, these two functions are built for multi-dimensional sets of data, right? You're not going to take the maximum of a variable holding one data value, right? There are also functions that create these multi-dimensional variables. And two I'd like to go over today are ones and zeros. So let's say, I don't know, uno becomes ones of, we open the parentheses, we say n, we see size 1, size n, we don't really know what it's asking for, right? So if we put a number here for n, and we close the parentheses and run it, uno is a 2 by 2 double, all with the values of 1, right? So what this does, the ones function does, is it creates a multidimensional set of data corresponding to n by n, in this case 2 by 2, right? So if I were to type in, say 10, it's a 10 by 10 set of ones, right? And zeros is basically the same way. Instead, it creates a 10 by 10 of zeros, right? And so when we saw that size 1, size n, we can also type in, let's say 1, let's say 3 by 6. Run it to 3 by 6 now. 3 by 6, right? Ones is the same way. So the last two functions I'd like to go over with you guys are size and length. And so we'll start with size. So the syntax for size is, what I like to do is name it row call, two variables become size of, let's say, A. Run it. Row becomes 2, call becomes 5. A was a 2 by 5. So what it does is it takes the size of whatever data set we assign here, right? Row holds the number of rows, call holds the number of columns. Just because they're called row and call doesn't mean they're going to hold the value of row and column. What it does is it spits out row, column, and then eventually layer when we get into that stuff. But for now, just know row comes first, column comes second. If we were to use a vector, C, we'd see that row is 1, column is 4, because C was a 1 by 4. If we were to use the length function, so let's just say L becomes length of, let's say, C. L is 4. C was a 1 by 4. If we were to say A stores a 5, A was a 2 by 5. So what length does is it stores the greatest dimension into the variable, right? So the greatest dimension was the number of columns for C, so it stored a 4 because there were 4 columns. For A, the greatest dimension was, again, the columns, but it stored a 5 because there were 5 columns, right? So that's about all I have for you guys today. I appreciate you watching this video. I appreciate you tuning in. I hope you guys got something out of this, and I will see you next Sunday.